Hi, Assalamualaikum. My name is Daya Nusaliha binti Muhammad Noor and my metric number is B0920102113. I would like to introduce my group mate for assignment BMMH 2303. First, Muhammad Azim Aiman bin Hazman. Metric numbers B0920101111. Muhammad Qayyum bin Suhaimi B0920104339. And Ain Bashirah binti Kamarul Zaman B0920102299.
Hi, Assalamualaikum. My name is Ain Bashirah binti Kamarul Zaman. My matrix card number is B0920102299. So today I would like to discuss question number 2, number 5 and number 6. So first question is question number 2. A 600 megawatt steam power plant which is pulled by a nearby river has a thermal efficiency of 0.35. The question is to determine the rate of heat transfer to the river water in megawatt. So first we need to know the value given. 600 megawatt is W dot out because power plant produce the output. And 0.35 is value for thermal efficiency. So first, to solve this question, we use the eta formula. Eta equal to W dot out over Q dot H. And then we need to modify the eta formula to find the Q dot H value. So Q dot H equal to W dot out over eta. So we insert the value 600 megawatt over 0.35. We got the Q dot H from value 1714.3 megawatt. After that, we can find the value Q dot L. We use Q dot L formula. Q dot L equal to Q dot H minus W dot out. So we insert the value inside the Q dot L formula 1714.3 minus 600 megawatt. So we got the value Q dot L 1114.3 megawatt. So next question is question number 5. The refrigerator in a kitchen receives electrical input power of 130 watt to drive the system and it rejects 300 watt to the kitchen. First question is question number A. Find the rate of the energy taken out of the cool space in work. So first we use this formula we use W dot in formula. W dot in equal to Q dot H minus Q dot L, and we modify the formula to find the Q dot L. Q dot L equal to Q dot H minus W dot in. So we insert the value 300 watt minus 130 watt. So we got the Q dot L value 170 watt. Next question is question number B. Question B. Find the COP of the refrigerator. Now, to solve this question, we use a COP formula. COP equal to Q dot L over W dot in. So we insert the value inside COP formula 170 watt over 150 watt. So we can eliminate the unit. We got the value COP 1.31. Next question is question number 6. The houseful refrigerator with COP of 1.6 remove heat from refrigerated space at a rate of 62 kilojoule per minute. First we need to know the value given. 1.6 is COP value and 62 kilojoule per minute is Q dot L value. First, to solve question A. Question A is the electrical power consumed by refrigerator in kilowatt. First, we need to change the unit of the QL first. Q dot L equal to 62 kilojoule per minute times with 1 minute over 60 seconds. So we got the value Q dot L in kilowatt 1.033. And then we use COP formula to find the W dot in. We modified COP formula, so we got W dot in equal to Q dot L over COP, and we insert the value inside this formula. 1.033 kilowatt over 1.6, so we got the value W dot in 0.646 kilowatt. Next question is question B. Question B is to determine the rate of heat transfer to the kitchen in kilojoule per minute. So we use W dot in formula. W dot in equal to Q dot H minus Q dot L in kilojoule. And then we need to modify the formula to Q dot H equal to Q dot L plus W dot in. And so we insert the value 1.033 kilowatt plus 0.646 kilowatt equal to 1.679 kilojoule per second, and then we need to change the units. 1.667 kilojoule per second times 60 second over 1 minute, so we can eliminate the second. So we got the value Q dot H 100.74 kilojoule per minute. That's all for me. Thank you.
Hi, and I will start with number 7. An air conditioner produces a 2 kilowatt cooling effect while rejecting 2.6 kilowatt of heat. What is your P? So as usual, we draw and put the info first. Q dot L equal to 2 kilowatt and Q dot H equal to 2.6 kilowatt. Then we look for question, and question asks for COP. Formula for COP is COP equals to Q dot L over W dot in. So we find W dot in first using formula W dot in equals to Q dot H minus Q dot L, and insert the info. 2.6 kilowatt minus 2.0 kilowatt, and we got W dot in equals to 0.6 kilowatt. Then we insert the W dot in to the COP's formula. So we got 2.0 kilowatt over 0.6 kilowatt, and the answer for COP is 3.33. Okay, then we move to number 8. An air conditioner removes heat steadily from a house at a rate of 500 kilojoule per hour minute while drawing electric power at rate of 6 kilowatt. Okay, first we need to find the COP of this air conditioner. Then we draw first electric energy absorbed by the compressor and input the info. Q dot L equal to 500 kilojoule over minute and W dot in equals to 6 kilowatt. Okay, first we change the value of QL, insert QL to the kilowatt. Okay, Q dot L equal to 500 kilojoule over minute times 1 minute over 60 seconds, and we get the Q dot L 8.333 kilowatt. Then we can find the COP using formula COP equals to Q dot L over W dot in, and we insert the info back. 8.333 kilowatt over 6 kilowatt, and we got the COP equals to 1.39. Okay, for question 8B, we should determine the rate of heat discharged to the outside air in kilojoule per minute. Okay, to find the Q dot H, we can use the formula of W dot in equals to Q dot H minus Q dot L, and rearrange to Q dot H equals to Q dot L plus W dot in, and insert the info. 8.333 kilowatt plus 6 kilowatt, and we get the Q dot H equals to 14.333 kilowatt. To change to the kilojoule per minute, then we times with kilojoule over second times 60 second per 1 minute, and we get the value of Q dot H equals to 860 kilojoule per minute. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and hi to everyone. My name is Muhammad Hazim Aiman bin Hazman from BMMMM 1/1. My number metric is B0920101111. Now, I would like to explain the answer for tutorial chapter 4. The question given is, a residential heat pump has a coefficient of performance of 2.4. How much heating effect in megajoule per hour will result when 2.1 kilowatt is supplied to this heat pump? So this is the example answer for the question 9. The formula is QH equal to coefficient times 2 watt net. So we put the value of coefficient, which is 2.4 times to 2.1 kilowatt, and we times to 3,600 second per 1 hour. And then we get the answer 18,144 kilojoule per hour. And then we convert to 18.14 megajoule per hour. The next question is, a heat pump with a coefficient of 1.5 supplies energy to a house at a rate of 75,000 kilojoule per hour. Determine the electric power drawn by the heat pump in kilowatt. First of all, we need to exchange a rate 75,000 kilojoule per hour to the kilowatt. So QH over equal to 75,000 kilojoule per hour times to 1 hour over 360 seconds. And we get 20.833 kilojoule per second, and we can get 28.83 kilowatt. So we want to find the power drawn. We need to derive the equation from coefficient equal to QH over watt net, which is watt net equal to QH over coefficient. And then we insert the value, which is 20.833 kilowatt over 1.5, and we get the 13.89 kilowatt. Now, the question is the rate of heat removal from the outside air in megajoule per hour. The equation is QH equal QL plus watt net, and we need derive the equation, which is QL equal to QH minus watt net. The value of QH we get from the A, and the value of watt net we get from the A also. So we insert the value 20.833 kilowatt minus to 13.89 kilowatt, and we can get 6.9433 kilowatt. And we need to convert it from 2 kilojoule per hour, which is 6.9433 kilojoule per second times to 360 seconds per 1 hour, and we get to 24,669 kilojoule per hour, and we need to convert it 25 megajoule per hour. Okay, now the last question from me, which is, a heat engine is operating on a Carnot cycle and has a thermal efficiency of 75%. The waste heat from this engine is rejected to a nearby lake at 13 degrees at a rate of 800 kilojoule per min. Determine the power output of the engine in kilowatt. First of all, we need to find the QH, which is the equation thermal efficiency equal to 1 minus QL over QH. So we input the value, which is 0.75 equal to 1 minus to 800 kilojoule per min divide to QH. And we can get the answer for QH, which is 3,200 kilojoule per min. And then we need to find the watt net out, which is the equation watt net out equal to thermal efficiency times 2 QH. And we need to input the value, which is 0.75 times 3,200 kilojoule per min. And we can get the answer 2,400, but we need to convert to kilowatt. So 2,400 kilojoule per min times to 1 min per 60 seconds, and we can get the answer 40 kilowatt. Okay, next, the temperature of the source in degrees Celsius. So we need to find the TH. The equation is QH over QL equal to TH over TL. So we need to derive the equation, which is TH equal to QH over QL times 2 TL. So we need to insert the value, which is the value we can get from the equation. 3,200 kilojoule per min over 800 kilojoule per min times to 286 Kelvin. And we can get to 1144 Kelvin. So we need to convert to degrees Celsius, which is 871 degrees Celsius. So that's all for me.
Bismillahirrahmanirrahim. Assalamualaikum. So my name is Muhammad bin Suhaimi. My metric card number B0920104339. So today I will explain about the question number 12, which is question, a heat pump operates on a Carnot heat pump cycle with a COP of 7.9. So it keep a space at 24 degrees Celsius by consuming 4.25 kilowatt of power. So determine which it have two question. So question A, the temperature of the reservoir in Celsius from which the heat is absorbed. So for the question B, which is the heating load provided by the heat pump in kilowatt. For the question A, which is the formula of COP horsepower. For the question A, which is the formula of COP horsepower, which is equal to 1/1 minus with temperature L divided by temperature H. So we put the value, which is 7.9 at COP, and then we didn't know about temperature L, so we put temperature H, which is 1/1 minus bracket temperature L divide by 24 plus 273. Okay, after that we got the answer, temperature L equal to 259.4 K. Okay, after that we got in value Kelvin, so we transfer it to Celsius, which is the answer, the final answer, negative 13.6 Celsius. For the question B, as we can see, it have a same formula. So COP horsepower rev equal to QH over W net inlet. So we don't have the value of QH, so we put the formula, we exchange, which is the value we have is COP HP times by W net. So 7.9 times by 4.25 kilowatt. Okay, then so the answer we got 33.6 kilowatt. So because the question asked for kilowatt. Okay, right now we go through for the next question. Okay, let's we go through the question 13, which is the question: can a refrigerator operate in a room in which the temperature is 25 degrees Celsius? So the refrigerator consumes 500 watt of power when operating and has a COP of 3.5. So determine the question A, the rate of heat removal from the refrigerator space in kilojoule per minute. Okay, for the question B, which is the temperature of the refrigerator space in Celsius. Okay, so let's go through by the equation. Okay, let's we go through the question 13. Okay, right now we go through the solution, which is for the question A, COP R equal to QL times by W net inlet. Okay, so we know the value that we have, COP and W net, and then we make it multiply, W net multiply by COP. After that we insert the value, which is 500 watt times by 3.5, and then we get the answer 1.75 kilowatt. Okay, after that we need the answer in kilojoule per minute. So 1.75 kilojoule over by second times by 60 second over 1 minute, and then we just cancel. After that we got the final answer, so 1.75 kilojoule per minute. Okay, for the question B, the formula is quite similar, but it has different. So we put COP R equal by 1 over TH time divided by TL minus by 1. The previous formula is different because TL divided by TH. So which is here, right here, we insert the value 3.5 for COP, and then TH we got the value, so 25 plus by 273. Okay, and then after that we solve it, so we got the answer 231.8 Kelvin. Okay, but the question asked for the Celsius, so we need to transfer, and so we get the answer negative 41.2 Celsius. Okay, so thank you for watching.